All right, and welcome to the lesson 2.3 notes, postulates, and diagrams. Definitely split into those two parts, postulates and diagrams. So we'll lay out these 7 different postulates involving figures and really things that we've talked about so far. Just kind of giving them a formal postulate name so that down the road, potentially we could end up using these as part of an explanation, right? Because we said in the previous lesson that a lot of what we do in geometry is deductive reasoning, being able to use facts and definitions and properties and postulates and laws of logics to create a logical argument. Okay, so that's kind of what we're doing here for the first part. Second, I think hopefully the second part will be very sound very familiar. It's really getting used to using some of the symbols that we've kind of added since early on in chapter 1 to make our own and then interpret other diagrams. Okay. So let's run through these postulates. Let's get that part of it done first. Yeah, we added these all to our notes in class through any 2 points. So let's just go. Here we go. 2-point postulate. Through any 2 points exists exactly 1 point. So you've got 2 points through points A and B. There exists exactly one line L. Right? There was not more than one line that we could draw. We could name it differently, but it's always going to be right that one line. All right. Second one. Right along with that same picture, if we have a line, so if we start with line L, it contains at least 2 points. At minimum, it has to. If it's just a single, then it wouldn't be called a line, it would be a point. All right, so it has to have at least 2 points. We know that there's going to be an infinite amount more than that, but we're kind of saying the other end of it, that a line contains at least 2 points. All right, so postulates, remember before you're all already up in arms, that these are all should be things that hopefully that we accept as like, yeah, that's a fact, kind of thing. So hopefully nothing here is going to be like, wow, that's a really cool concept. That's really interesting or really deep. Usually they're very intuitive, or things that we may have even talked about already. So there's 2. Next one, it's called the line intersection postulate. And this is definitely something that came up in chapter 1 when we defined what an intersection was. We say the postulate states that if 2 lines intersect, then their intersection is exactly 1 point. Okay, so the custom way to say that for this figure would be the intersection of line M and line N is point C. Using symbols, naming lines the way we've named them. There we go. A couple more here. Let's add them to our notes. Let's just go one at a time. The 3-point postulate says that if we have any 3 non-collinear points, remember it can't be in a row, non-collinear, there exists exactly 1 plane. All right, so we've got points D, E, and F as non-collinear points. The only plane that could contain them would be then, in this case, plane R. Just like the previous postulates, it's kind of the converse of it. The plane point postulate says if we start with a plane R, then we have to have at least 3 non-collinear points. Same idea that we know a plane is actually going to contain an infinite amount of points. We're kind of going the other end of the spectrum, that we need at least 3. Like 3 is the minimum in order to define or identify a unique plane. All right, the plane point postulate. 2 more involving planes here, both of them. So if 2 points lie in a plane, so points D and E lie in plane R, basically there's no way then that the line containing them doesn't also lie in that plane. So like if D, E are in plane R, then for sure that line DE has to also lie in that plane. It couldn't like pass through the plane, punch through it at a spot or whatever. So that's the plane line postulate. And last but not least here, I think hopefully the plane intersection postulate, again, came up when we defined, I think it was 1.1, the very first lesson, that when we defined what an intersection was, we said that if 2 planes intersect, then their intersection is a line. We're just assigning it a fancy name here, so for future justification purposes. So the planes intersect at line L. All right, so what are we going to do with these? What are the questions look like that I would be asking you that involve these postulates? We don't have to memorize them by any means. So let's look at some examples of how we would use them, okay? So the first example one here is just state the postulate illustrated by the diagram. So I'd obviously want to make sure I can see my figures, my postulates. So I'm kind of going back and forth. If this, then that. So what's different? Well, basically, if two lines intersect, then they intersect at just one single point. So I'm going to flip back in my notes and say, all right, what's that one? That was the line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. Awesome. So that's what I'd be saying, the line intersection postulate here for this first one. Let's get a pen going here. For part A, I would say, if I can get my pen figured out, the line, intersection postulate. All right, that's the postulate illustrated by the diagram. It says line. All right, let's do the next one. I think very similar. It's the one we finished with. So if two planes intersect, then their intersection is a line. I don't have that postulate memorized. What was that one called? The plane intersection postulate. So I'd come to my part B here and just say that was the plane intersection postulate. All right, so far so good. We're just using our notes to look for specific examples of maybe something we see in a figure. I think example 2 here, sometimes people struggle with, where it's saying, okay, you're getting a nice detailed figure, lots of stuff going on, looks like a couple planes intersecting, some points on plane Q, so point V, Y, and W are all on the shaded plane. This line here named line B, we've got point X and Y lying on plane P, so there's lots of stuff going on here. Here's what we're asked to do. Use the diagram to write an example of the plane point postulate. So what does the plane point postulate says? Let's see here. The plane point postulate, make sure I'm doing the right one. I feel like I already screwed it up. The plane point postulate. Where is it? Right here. The plane point postulate says that a plane contains at least 3 non-collinear points. So I'm essentially going to restate that, and it's going to look kind of something like this. Plane R contains 3 points, which are D, E, and F. I'd customize it a little bit. So basically, I'm asking us to restate the postulate, but make it more specific. This is a very generic statement. Let's customize it for our picture. So the plane point postulate, we want to say which plane contains which points. So plane, I'm going to kind of restate this here. Plane, let's see, I need a plane with 3 points in it. I think we're going to have to probably go with plane Q. Contains non-collinear points and then let's list them. Which points are we talking about? Whoops, I don't think I needed that there. Oh, where'd my eraser go? Contains points V, Y, and W. All right, there we go. Plane Q contains non-collinear points V, Y, and W. So that's the idea. When it's not a one-word answer, it's not a one-symbol answer. Sometimes people just say plane Q or points V, Y, W. It's kind of a restatement of the postulate. So looking at part B here, it's just going to a different postulate. So let's find the plane line postulate. Plane line postulate is right here. If 2 points lie in a plane, then the line containing them lies in the plane. So use this as like your model here. Like, I think this is very, very good. Points D and E lie in plane R. So DE lies in plane R as well. So we're going to do basically that exact same thing, except for our specific figure. So let's start by listing some points that lie in a plane. I think we're going to probably have to go with this line right here, points X and Y. So I would say something like points X and Y lie in plane P. So line, and now I'm talking about this line right here. It's dashed because it's kind of hidden behind this shaded plane here. But this line, however I want to name it, I could just call it line XY if I wanted to, or change up and say, so line A also or must lie in plane P. All right, so it's a restatement of the postulate for a specific figure. Let's look at the last one. This is more just kind of identify the postulate. Which postulate allows us to say that the intersection of line A and line B is a point? Line A is right here. Line B, it's specifically point Y, so we could have said that, but it's just a point. So let's go and look. Where's that one that was talking about the lines intersecting? All right, here. That's called the line intersection postulate. Two lines must intersect at one point. So we would say the line intersection postulate. Whoops. And there we go. All right. So that's pretty much how we're going to use those postulates. It's as much as being able to identify and label and talk and converse with some of those symbols and abbreviations that we did earlier on in the year or earlier on in chapter 1. Just kind of connecting them to some names like the line intersection postulate. So there we go. I think that's probably enough to say, hey, all right, we've done the identify postulates and using diagrams. Those are what the questions would look like. The second part of the lesson now is sketch and interpret diagrams. Okay, so let's just run through real quick here. Not a lot to add to our notes. I think the way we've been doing things all year is going to kind of set this up here where we don't have to really add a lot. When we look at a figure, there's definitely some things that we can always conclude. So can we get them all in here close? That everything that we're seeing. So here's some stuff that we know for sure without being told this, that we can assume that all these points, let's put a little point here. This figure's from the book, but it should have probably a little point at B. Sometimes you'll see it, sometimes you don't, but all the points are coplanar. So A, B, C, D, and E are all in the same plane? Absolutely. A, B, and C are collinear? Absolutely. We see them all lying on the same line. Line AC, ray BD and ray BE intersect at point B. Yep, that's part of kind of just, we can assume that. They all look like they're starting there. It's not like there's some weird spot that one is starting at differently. Angle DBE and angle EBC are adjacent because they're sharing this point. They're sharing this ray. And ABC, angle ABC, right, the vertex there is a straight angle which measures 180 degrees. That's all things that we can assume, we've talked about. And then point E lies in the interior of angle DBC. So here's angle DBC. Point E is in that interior of that angle, so somewhere between between D and C, I guess. All right. The things that we can't conclude are the things that require markings. We don't know congruence. We don't know midpoints. We don't know angles congruent. We don't know perpendicular or right angles. Okay, so really for now, I think these are the three symbols that we need to kind of be on the lookout for. Like if something's asking about perpendicular or a right angle, I need to see that symbol. If I don't see it, I don't know it. Same thing with B, potentially being maybe the midpoint of segment AC. As it was before, I mean, it looks like it's in the center, but we don't know that, right? I need to see those tick marks, and then I could definitely conclude that, oh, hey, absolutely, B is the midpoint, or AB is congruent to BC. And then it's very similar with the angles. That same thing must be true. I need to know, based on the markings, the congruent arc markings, for us to say that, hey, ray BE is an angle bisector of angle DBC. Well, how do you know that? Because it divides it into two congruent angles. All right. So what goes along with this? Part of it is the sketching. So being able to sketch our own diagram, given some information. Again, symbol interpretation, line versus segment, showing congruent segments. All right. That's really telling us, hey, we got to get some markings involved here. So here we go. Let's do it. Let's sketch this diagram. So showing that line TV intersecting PQ. So I'm going to start with PQ. I like to maybe have not the straightest segment, but I think good enough. There's segment PQ. Intersecting, so I need line TV. I'll change up the color on us here. So here's going to be my line TV intersecting PQ at point W. So we know for sure that this has to be point W. And the reason I was waiting to kind of put TW, because I hadn't read the whole thing necessarily, or I hadn't said it as I was drawing it, I want TW, that's why I put W on first, but I need TW to be congruent to WV. So, however far I decide to space out T, I want to go about that same distance for my V. And let's see here, TW should be congruent to WV. I think we've done a decent job as far as putting him somewhat accurately. The thing that's a must-have, absolute, probably at least half the point, well, not half the points, but a good portion of the points is I need to show that TW is congruent to WV, and we use it using those tick marks. So that's the last kind of piece of the puzzle that I got to have. And you can almost go down and check. All right, do we have a line TV? Yep, I got arrows on the ends. It's a line. It's continuing forever. Intersecting segment PQ. So PQ is kind of like a finite piece at point W. Point W is labeled. So I'm kind of just going through and checking all this stuff off. Check, check, check. And then did I mark segment TW? So just this piece. And segment WV being congruent. Yep, I marked that. So I'm feeling pretty good. So, on a 4-point problem, they each maybe carry a point. All right, so that's the idea. Like I said, the other stuff we would see are symbols involving angles and perpendicular. We're looking at one here. Last thing, new vocab word for us. A line is perpendicular to a plane. We've talked perpendicular, but it's always been lines in like a single plane. So here's what we've talked about already. We've talked about two lines or two line segments. Ooh, it's not a very great sketch, but hey, just so we got done talking about, I can indicate to a reader that, hey, I want these to be perpendicular, intersect to form a right angle by adding that symbol. So we've talked about it, just two lines in a single plane. The reason this one's different is we've got a line perpendicular to a plane. So it's that one where you've got essentially line T, you're kind of coming down and punching through a single point on a plane and passing through it. By definition, like if we want to say that this is perpendicular, it needs to be perpendicular to all the lines that pass through that point at that point. All right, so we could definitely say in the diagram, a line is perpendicular. Line T is perpendicular to plane. I guess this is plane A right here, because of it's perpendicular to lines P and lines Q. Definitely a tough one to sketch if you're adding this to your notebook, which you should, just because of that three-dimensional kind of quality. You've got the two-dimensional plane, this line in a separate dimension kind of punching down through it. So a little bit of a spatial kind of just seeing what's going on there. Not a huge part of what we'll do, but definitely worth just kind of noting. All right, and then the last thing we got to look at is kind of figure interpretation. So can we sketch stuff? Sure. And then, all right, interpret a diagram, interpret a figure. So here we go. I'm getting similar looking to one that we had before with the postulates, except now it's just which ones can we and can we not assume? So E, D, and C are collinear. Let's find them. Where's E, point E? It should say points there. Points E, D, and C are collinear. Yeah, that can be assumed. I can see a line passing through. It's passing through E, D, and C. So yeah, that can, let's just say like this, which of the following statements can not be assumed? This one can be assumed. Or, like that's another way to ask kind of that same question would be, are these true or false? Like that's true. E, D, and C are collinear. We can assume that. Let's look at the next one. The intersection of segment BD. So where's segment BD? It's right here. Only from this spot. So there's segment BD and segment EC. So let's change over here to segment EC. The intersection of them is point D. Again, it should say point there. Is point D? Absolutely. Yep. That's where those are intersecting. So that's another thing that, yep, they're both kind of passing through that point. Two segments would always intersect at a single point. So absolutely, we'll kind of word it the same way. We can assume that, or we could say that that's true. Let's look at these next couple. Just, at first glance, as I'm kind of looking at it here, these are both, remember our symbol for perpendicular, BD is perpendicular, EC is perpendicular. If I clear off some of the stuff on my, I keep clicking the wrong one, on my picture here, I think I'm probably going to have a hard time saying anything about perpendicular because we're missing those symbols. I don't know these planes are perpendicular. I've just obviously added all those, but anything that's going to ask me about perpendicular is going to be, I don't think, able to be answered because we need those markings. So let's take a look. Where's it's asking is BD perpendicular to EC, those two segments we just talked about here. Gosh, they sure look like it, right? It looks like that's a 90-degree angle, a right angle, but without that marking, so in one of these four corners, I can't make that conclusion. So we definitely cannot assume that. It's not necessarily false, so I don't want to say like, hey, that's false. That's totally it could be true, but we definitely cannot assume it. All right, last one, same idea. This is more the concept we just talked about. Line EC being perpendicular to plane G. And it's the same argument as before, that unless I saw like a perpendicular marking here, we can't assume anything's perpendicular. So it's another one that we cannot assume this. Again, we could say false because it's not necessarily true. So that's the idea, is being able to go through and you're looking for markings. We really couldn't answer anything about congruent. I don't know, like that AB, it could ask a question, is segment BA congruent to segment BD? They might be, but we don't know. Is segment, whoops, probably need a pen, segment ED, whoops, congruent to BD? Again, same reason, I don't know. Angles congruent, not really a whole lot. So this one's missing a lot of markings as far as things that I would be able to conclude. The planes intersect at line BD. Yeah, that would be something we could conclude. I can see it on there. The planes intersect. It's going to be a line. I would just be able to name it line BD. So there we go. I mean, one of our shorter lessons, partially because it's building on things that we've talked about as far as some of those concepts that were in the postulates. And then even the sketching, we've talked about perpendicular, we've talked about congruent segments. It's kind of just building on them, putting them together. So there we have it. There are our lesson 2.3 notes. I think we can call it a wrap on that. That's all I've got. So I will see you in future lessons.